Alright, welcome to Chemistry Video 1.2 on the scientific methods. Just a reminder, put away all distractions, maximize this video screen if you can, pause, rewind frequently, and write any questions you have in the margin. Alright, main ideas of this video will be to identify common steps of the scientific method, know the difference between a theory and a scientific law, be able to understand the difference between qualitative and quantitative data, and be able to understand the difference between dependent, independent variables, and constants and controls. Let's go! So the scientific method, you've probably had it since at least 6th grade. The scientific method is a systematic approach to doing research and to verify the work of others. It's how scientists keep each other in check and make sure their work is correct. Although it might seem like a rigid rigid order of what you do, oftentimes you can jump around between these different things. You might be doing an experiment, make an observation, and then have to do figure out a new hypothesis and do a different experiment. So oftentimes you might be in different areas here and then kind of bounce around a little bit. So let's start off with observations. Observation is the act of gathering information. And it's basically another word for observation would be a measurement. And measurements are usually made. Measurement? Sorry, it's not very good handwriting. Measurements are oftentimes your quantitative data. When you make a numerical measurement, like how long something is, how hot something is, how much mass there is. Qualitative data is usually when you use your 5 senses, some kind of physical characteristic you're describing using the 5 senses. And again, quantitative data is numerical data. A hypothesis is a tentative explanation, and when something is tentative, it means it's kind of temporary. It's like your temporary explanation for what has been observed, and you're trying to explain what's happening there. And then basically a hypothesis must be a testable statement, so that way you can test it in an experiment. An experiment is a set of controlled observations that test your hypothesis. And ideally, we test one variable at a time to see what its effects are on the rest of the experiment. Now, these two things usually get confused between two people's, how you remember them. Remember the independent variable is changed by the investigator. So in an experiment, the variable that you try to test and change it, that's called the independent variable. And then what we do is we measure the other variable, and the other variable is called the dependent variable. And this is the one that we're going to measure or observe. And why it's called a dependent variable? Well, it depends upon what the independent variable is. So we change the independent variable around, the investigator does, and then this variable depends on that, and we measure how it does change. Also, an experiment, I'm going to skip to the second one for a second here. Oftentimes, there's more than one variable. So, for example, in a chemistry experiment, we could worry about the temperature of the experiment, we could worry about the pressure, we could worry about the volume, and oftentimes there's more than 2 variables here. Well, ideally what we try to do is try to keep something constant. So for example, maybe we'll try to keep pressure constant, and then we will change the temperature throughout the experiment, and then we'll measure this one over here. The variables that you don't change or you try to keep from changing, we call those the constant in the experiment. And then the control experiment is oftentimes your first experiment. The one where you don't do anything particular, you just kind of do the experiment. So oftentimes the first trial would be your control experiment, and we use it as a standard for comparison. So as we go and change the temperature to here, to here, to here, we always go back and compare to the first trial our control. A conclusion is a judgment you make at the end of your experiment. It's a judgment based on information you obtain. And when the data supports the hypothesis, it indicates it might be true. Okay? Please don't ever say that your conclusion proves something. It only supports. I'm going to cross off the word prove. We want to not use that word this year. Your conclusion can support something. There's always a chance that another experiment someday could not support your data or your hypothesis. So therefore, we always say your hypothesis can only be supported by the experiment. When the data does not support your hypothesis, there's 2 things that can happen. We can discard our hypothesis, it was crappy, or you can just modify parts of it if you think that those modifications will make it better. And if that's the case, after you modify it, you should jump back in and experiment one more time to see if your modified hypothesis is better. Lastly, we have theory and scientific law. If a hypothesis gains a lot of support by many experiments, it becomes a theory. So an explanation that has been supported by many experiments is what we call a theory. And notice I underline the word explanation here for theory. That's what theories do. They try to explain something. Whereas a scientific law is just a summary about what is found in nature. It's also supported by many experiments, but it's just a summary of what happened. So let me kind of explain the difference here. Theories explain why something happens. So for example, if I have a box of gas particles bounce around this box, when they hit the container walls, they cause pressure on that box. And the more times they hit the walls, the more pressure you have. Okay? So we have a theory called kinetic molecular theory that says when you increase the temperature, these particles move faster. And if they move faster, they hit the container walls more. Therefore, the pressure goes up in that box because there's more collisions now. And that's an explanation. So therefore, it's called a theory of what we're using. A scientific law basically summarizes what will happen. So a scientific law might be something like this. If you increase the temperature, the pressure will rise. That's just what's going to happen. It doesn't explain why it happened, it just does happen. There's actually a formula for this, and it's T1 over P1 equals T2 over P2. And oftentimes scientific laws, they will have some kind of equation that goes with them. So the difference between a theory and a law is theories explain why it happens, whereas scientific laws just say it's going to happen without saying why. Alright, that's it about the scientific method.